Understanding the fundamentals of computer programming starts with learning the basics of how a microprocessor-based system works. Let's start by reviewing how a microprocessor works with permanent and temporary memory storage to accomplish its operations. The data that was saved on your computer since the last time you used it, and perhaps turned it off, is in the computer's permanent memory. These devices go by different names these days, like solid-state drives or SSDs, but they were originally called a hard drive at the time I started using personal computers. My first computer didn't even have a hard drive, and I had to load programs onto it from a magnetic cassette tape. Your computer also has temporary memory that will only remember data while it has power. This memory is typically in a dedicated bank of expansion card slots, collectively called the Random Access Memory, or RAM. You might be asking yourself why the computer needs both permanent and temporary memory, and why doesn't it just use permanent memory for everything? It turns out that the logical circuitry needed to remember information when the power is turned off is relatively slow, meaning that use of the permanent memory is much slower than use of the random access memory. Many incremental calculations, and by many I mean on the order of trillions or so on a modern computer, are necessary for a microprocessor to do its job. And there's no point in taking the time to store the results of all these incremental calculations to permanent memory when they do not need to be remembered the next time the computer is turned on. The microprocessor is part of the logic circuitry of the central processing unit, or CPU, of your computer. The CPU in the typical computer at the time of this video needs to relay 64 bits of data at a time with other components, so it's going to have a lot of pins on the back to connect with the motherboard. Despite its size, you're not likely to be able to see this chip in your computer because it generates a lot of heat when operating and will usually be connected with conductive thermal paste to an air or water-cooled heat exchanger. Your computer will have many other components that I have lumped into a box called interfaces for the purposes of this video. These include your input devices like keyboards or mice, as well as your monitor's visual interface via the graphics processing unit, or GPU. Finally, all these components talk to each other through sophisticated data transfer circuitry called buses, specifically address or data buses. These buses are governed by their own controllers that I have not shown in this diagram to keep it simple, and you generally don't need to think that much about how buses function when programming, so I won't be talking about them in any more detail. The function of memory you do need to think about when programming is how the data are stored at given addresses in the memory space. For both the permanent memory and RAM, the memory space is broken down into parcels of content that each have their own address that defines its location. The processor is then able to access the stored information by putting a specific location on the address bus, then read the content of that address on the data bus. This process of storing and retrieving data from memory is important to think about when programming. When you declare and assign a variable, you're basically giving a name to a collection of addresses in RAM. And one way or another, the computer has to know the data type you are assigning to the variable so it can reserve enough addresses to provide the space in memory for the assigned value. Knowing the data type of the variable is also critical for the ability to retrieve the appropriate addresses for recalling the assigned value later. This nature of RAM is why understanding the nature of data types in your programming language of choice is so critical to effective program design.